Hello, my name is Alex Mackin and I'm from the University of Bristol. Here is a presentation on our poster, a subjective study on videos at various bit depths. Recently, the video parameter space has been extended to deliver more immersive experiences, and this has been through increased spatial resolution, such as 4K and 8K formats, increased frame rates up to 120 frames per second, and increased dynamic range and color gamuts. So this is the 10 and 12 bits per color channel formats. Coding games can be achieved on these formats by exploiting the properties of the human visual system through spatial temporal resolution and bit depth adaptation. This is where the resolution of the video sequence is downsampled before compression and transmission and upsampled at the display. We have previously investigated the relationship between visual quality and both spatial and temporal resolutions. We have yet to investigate bit depth. Therefore, we introduce the BVI-BD video database. This contains 12 5-second video sequences captured at UHD, a frame rate of 60 frames per second, and a bit depth of 10 bits per color channel. During experimentation, the source sequences were downsampled to 8, 6, 4, and 2 bits per color channel using 3 separate methods, which you can see on the left here. The first one is a linear downsample and a linear upsample. The second is an error diffusion downsample and a linear upsample. The third is an error diffusion downsample and a novel adaptive Gaussian filter that we have developed for this paper, and this is used for upsampling. So in the first method, you can see as we reduce the bit depth, we're getting these harsh color contouring artifacts. The second method gives this strange noise artifact, whereas the third method, the adaptive Gaussian filter, provides an over smooth representation, but one that's visually pleasing to a human observer. So we had 14 participants view all of the source sequences, and you can see the results in the figures provided. You can clearly see for this experiment that above 6 bits per color channel, there is no significant difference in visual quality. This is showing that for this experimental setup, that there is no point downsampling the content to above 6 bits per color channel, which is an interesting thought, because most of the literature is proposing that we increase bit depth to 10 and 12 bits per color channel. But this is probably only for displays with very high luminance or contrast ratios. We'll see here that out of the 3 methods, the adaptive Gaussian method provides the best performance down to 2 bits per color channel. Alongside subjective evaluations, we also looked at some objective quality metrics, and we benchmarked them on our data sets. PSNR performs very poorly. The other metrics perform okay, with VIF providing the best performance. Even though VIF has the best performance on the database, it is still possibly not good enough to perform bit depth adaptation in the future. Therefore, we are required to develop algorithms and quality metrics, not just for spatial and temporal adaptation, but also for bit depth adaptation going forward. Thank you for listening to our presentation.